I welcome you all to Model Driven Development and MDA. So, here in this session, we'll be looking at the principles of model driven development. We'll try to understand what are the different terminologies that are being used in model driven architecture MDA. Let's begin. Let's on the transition of objects to models. The objects oriented terminologies have started in the year 1980s. By 2000, it went into the evaluation. The models began over there, gaining some sort of stability. And then by 2020, that is the current year, it has been expected that they will be under evaluation. So, model principally is the representation of reality. It means that a model should not expect the thing to be represented which are outside the domain of system. So expressing a model, it's not equivalent to expressing something as a picture or as an image. People also called it as blueprint of the system, but blueprint terminology again has been stated way back the year 1998 at SEI. Moving next, here we can see that how this transition has happened from 1980s to 1995 to 2000. That is from the procedural technology to the object technology to the component technology and to the model technology. That is from imperative paradigm that is based on C, Pascal, like programming languages to objects and classes. They were being built using primarily with C++. Small talk, how many experimentations have been done in India and how professionally it has been used, that is not clear yet. Components, as we all know, that it's the smallest unit of software found to be functional, tested, and verified. So, components, based on components, there were been packages, there were been patterns that were been proposed in the year 1993, which were been called as design patterns related to subsystem design. The previous part to the design patterns was the architectural styles, and the later on is the EDONs, which speaks about the coding. Now models, they work around on meta model. If about metadata, we say it is data about data. For meta models, we should say that it is model about. So we have got there certain terminologies, that is UML, Unified Modeling Language, OCL, Object Constraint Language, the Meta Object Facility (MOF), the CWM, that is Common Warehouse Meta Model, XMI, that is XML Metadata Interchange, because the diagrams are required to be exchanged or interchanged while they are being migrating from one viewpoint to the another. We will have a look at that. So the basis thing was model transformation. In the first case it was procedural refinement. In the next case it was object composition, and in the last phase it was the model transformation. So why modeling is essential? If we take the uh, projection there, modeling is essential to human activity because every action is preceded by the construction of a model, that is implicit or an explicit. So typically, model is represented by a set of notations which have been used to represent the real facts in the world. Now, one of the things is that if you submit n number of queries to the system has got its own pattern of input, process, output, and feedback. Never forget this IPO model, that is input, process, output, and feedback model. So the system is required to generate some sort of output. Now, for a model, if the inputs are being given, the processing should be indicated, the output has to be judged, and the output should be the same as if the system would have generated it. It means that there should not be any deviation between the system generated output and model generated output. So they should be the same. I'm not talking about similar. They should be the same. Proceeding next is the metadata. We know metadata is data about data. It describes the data in a suitable form. So representation form is decided there. So it has to be precise, flexible, efficient, controlled. It has got structure. You all know that it has got structure. So this structure means that you are having this schema. Yeah. Syntax, it provides a means to represent one or more structures in flexible or extensible manner, and it provides mechanism for encoding, that is machine processing of metadata. Semantics means that it follows certain vocabulary, that is the domain it represents, the lexicon it represents, that has to be mapped up with semantics. So triple S, that is syntax, structure and semantics, they govern the metadata. Now schema, as you all know, it identifies, defines, organizes and constrains the elements in the set, their characteristics and descriptions involving both semantics and structures. Moving next is the metadata characteristic. It could be extrinsic or intrinsic. This has been derived from the terminology of the semiconductors, where extrinsic and intrinsic were being there of the two types. And extrinsic metadata, okay, just think about the purity of the data. It is existing independently of primary data being described usually in the indexable metadata base. So this indexing can be done by a variety of mechanisms which have been available, or intrinsic, existing as a part of primary data being described. So which one is powerful? Both of them. Intrinsic, they work on the primary data, existing primary data that is being described, and extrinsic, that is defining the something which is not being dependent on the primary data. Now durability and interoperability is also one of the concerns while designing the metadata system. So shortly, to revise, the things that we have studied with the normal forms, right from the first normal form to the fifth one, and Backus normal forms, the thing that is observable is quite clear that the certain units or certain fields of the database are being dependent on certain keys. The keys are providing the mechanism of access. Now, whether it is the part of that keys, if it is there as a part of those keys, it is the intrinsic, whereas extrinsic, where the shading is not being applied, they exist independently of primary data. But having too many kind of an extrinsic metadata structures is dangerous for the survival of the system. Why so? How to maintain the catalog of them and how to act on them is a serious situation. So now let us go up with the kinds of models. There could be mathematical models, biological, ecological, economical, meteorological, simulation models, and predictive models, which were being used mainly with the statistics and now in AI and machine learning. So we see that software systems representation is in terms of business systems, application requirements and execution platform. So a software system is a model of something, but what it is kind of an category bearing. So therefore, Software is but natural, it is complex and composite model. We are talking about intangible things, right? But in case of a model, what organization where it is supposed to function, architecture, that is infrastructure setup, applicative requirements, and the team building it, whether it is requiring too much kind of support and expressed in which language. So uh, there is something called as code-centric mechanisms to model-centric mechanisms. So we have to pass from the code-centric to the model-centric, that is DSLs, domain-specific languages, which is equivalent to GPL, okay, that is general purpose modeling language like UML. Going next, the systems can have multiple aspects. A model has got multiple aspects. So system S in reality, which is at layer 0, is represented by layer 1 M1, that is called as terminal model, which is associated with A, B, C aspects of the system. So mainly they are being known as MA, ME, MB, and MC. So M0 and M1 layering, one must understand first up, that is they are being represented by a terminal model, right? The reality, that is the set of objects, real world objects, is being represented at layer M0. To simplify this, at M1 layer, if I am representing a person's aspect, person as an aspect, right? So, representation in form of system could be Ram, Shyam, and Ganjam, right? Another aspect is process order. Order pizza, order burger, order uh, kite could be the another thing. Well, so try to understand it in this way. Now, which one is the model and which one is the system? There is a pipe, right on the left hand side downwards. You can find the pipe. The pipe is a system. Now, if you once you photograph it, okay, and put it up on the wall, it becomes a model, right? A model, a representation of the system. It is not the pipe in reality, right? But it is the model of the pipe. Okay. And then the representation of the model is a meta model, right? That speaks about the model. And then the meta model is the representation of meta model. Once again, I will repeat the channel. A system's representation is in terms of model, right? The system is pipe, okay? The photograph of the pipe mounted on the wall, okay? Its case, it is a model of a pipe. Model of a pipe doesn't mean that really you can use that, isn't it? But it should indicate the same kind of functionality that a pipe would have done, right? So now, about this photograph, if you want to have another photograph representing it, so it will look like another one, that is meta model, that is model about a model, and then meta model. So try to understand these labels, okay, system first up, then a model, then a meta model, then a meta model. So going now, just try to see to it real world, the real entities, okay, you can find the cat, okay, the dogs, okay, the fishes, the animals, right? They could be classified into distracting animals, right? Or other pet animals, isn't it? A pet has got name, weight. It can be a dog, cat, okay, or monkey even. Yeah. So you may create an category theory, right? and then you can create a meta model which has got class and property. The class is pet, the categories are dogs and cats, okay, and monkeys. Alright. Now what monkeys do eat, that could be the operation. What cat can eat, what dog can eat. Okay. Monkey likes fruit. Okay, but whether the cat likes fruit, dogs like fruit, exceptional cases are there, okay, where you must have heard that this dog, okay, likes Alfonso's, okay, because the mango season is ahead. Well, next is the layering that I have told you. See to it that M0 has been kept aside, which represent the system. We have to start with bottom-up representation, right, on the left-hand side diagram. The real world is represented by system M0, represented by a model M1, that is called as terminal model many of the times, and then which is conforming to meta model. It means that it is derived. It makes use of meta model to represent what? The system. So a meta model takes help of what? Meta model. So just see to it, system S, then M, then double M, then triple M. C1 and C2, they are in the conformance relationships, backward conformance. Going next. So a system is represented by a model conforming to meta model. Again, to remind you, meta model is model about model. What is a meta program? Program about program. Meta element, element about element. Meta language, language about language. Okay, so proceeding next, you have got the same diagram. Now, let us go through the first line. A model or a terminal model where it has been existing at M1 layer is a representation of a real object M0 conforming to a meta model M2, that is the next level. So if person is been modeled at M1 layer, M0 would be the set of objects representing the system S, that is Ram, Sham and Ghanshyam. A meta model M2 is representation of set of modeling elements M1, that is terminal model derivation depends on M2, but M2 is conforming to M3 and M3 conforms to itself and it defines meta model M2, right? Now what is the difference between meta object facility and UML? UML stands at meta model level. Right. The models that you have been drawing, the use case diagrams, the sequence diagrams, the state chart diagrams for your system, for the objectives or goals, right? They are derived from UML meta model. They represents the terminal model M1, right? So UML meta model is conforming to MOF. So what is the difference between MOF and UML? MOF deals with binary associations, whereas UML deals with n-ary associations. No association classes or qualifiers. Here there exists association class and qualifier. Direct references could be done in MOF because direct derivations are possible to UML meta model level. Navigation is been done through associations. Generalizations and dependencies are associations. And here in UML, they are meta classes. What is meta class? Class about class. Right. Now, there is no support for templates in case of MOF, but there are template meta classes in case of UML. So, no Purva awareness is there with UML. Purva stands for Common Object Resource Broker Architecture, right? So, let's take up the meta modeling terms now. Meta model, it describes information about models. It describes about meta models. Meta models can be defined using the same meta model. It can be compared to conformance and so on and so on. So a model has got three things to deal with. terminal model, meta model, and meta model. Proceeding next, these are what the layer of transparencies that we can see in OMG's modeling infrastructure. Layer of transparencies. User data, modeling concepts, that is all of your diagrams will be termed as modeling concepts at N1. UML meta model, we are going to visit it, okay, and you will understand what it is. And a meta object facility that is standing at the top. Look at the organization, isn't it? It's all structured, right? Here, the trio that has been interconnected, here it has been clearly mentioned, right? Here with the help of binary associations, right? Yeah, here, there with the case of UML meta model, they will be NR. Next, in MDA, M1 layer is conforming to M2 and all the M2 layers are conforming to M3, right? So one unique meta model is sufficient, and then you can have the derivation of the meta model. That is, in our case, that is UML, right? And you can have the language given by the meta model, and you can create the terminal meta model, which has to be unique. So there you should avoid repetitions as far as possible. Next is a model is captured in the meta model, which describes a platform. What is platform? It's a set of functionalities which are being abstracted from the user. User is not required to know the internal details of how these functionalities are being organized and how they collaborate with each other. So the model is captured in the meta model. So meta model describes the platform. You must have platform realization, and it could be primitive or composed realization. In primitive, you are having standard support for the platform realization. You can customize it in case of composed realization. Okay, so dual level implementation has been there. So system is represented by a model, but with the help of meta model, where the terminology and assertions both are belonging to collection kind of an separate enumerated data type. So terminology is a collection of concepts with their properties and relations, whereas the assertions are collection of additional rules. Remember that it is additions of additional rules, okay, by which the terminology elements can be constrained. Next thing is, this is very important to know, MDA levels, very important, CIM, PIM, PSM and PDM, which has been represented as code. CIM stands for Computation Independent Model, which means that it is an primarily dominated by a requirements model defining the system in its environment. PIM, which represents analysis and design models. So many of your models are either belonging to CIM, that is, or otherwise PIM. Now for static analysis, you can use use cases. For dynamic analysis, you can use the other diagrams, likewise the sequence, state chart and activity. And for structuring the system, that is for design model, you can use class component deployment diagram. PSM, platform specific, okay, it is the realization model. Typically, you have to tag the PIM elements to PSM element to generate the code. So that is PDM, that is for specific configuration artifacts. That is using this particular operating system, using this particular programming language and platform. Going next is the example of meta model. Just try to focus on the diagram. That is an actor and a use case. There is an include relationship. Extend is missing. Okay, no problem. An actor can have super actor, that is primary and secondary actors you can show, and they indicate their participation right through the association. Now, the client to the pet store indicate the system boundary, can buy something or can add a certain order. Alright. So add order, buy and client. These are the instances. They are representation of the terminal model. Whereas UML meta model gives actor, use case and the system relationship. Right? Just try to see to it once again this diagram. Add order and buy, they are the use cases. The actor is represented by the client. Pet store is the system. These are all the elements of the uh, what you can say the system at terminal model level. Terminal model level, that is M1. At M2 layer, that is UML meta model layer, you have got actors, use case and system. Going next, there is lot of many kind of types that are being indicated over here. That is definition of abstract syntax, that is concepts, relationships and well-formedness rules. Concrete syntax, shapes, layout and physical interchange formats. Semantic domains definition and definition of mappings between the domains. So this could be done by the XMIs, that is XML metadata interchange. So MOF defines a framework for implementing the repositories holding the persistent representation of the meta models, that is horizontal, different domains that are not more or less abstract than others. There is marketing, engineering, sales, right? Vertical, different level of abstractions of the same domain, that is middle where or applications specifications or component assemblies in terms of modules, business process modules and the business goals and strategies. Evolutionary, where in case different systems are ongoing or upcoming as it would be. So the difficult or hard to hit is the problem of heterogeneity, right? Either in terms of evolutionary models or horizontal. Proceeding next is the same kind of a terminology, that is the real world represented by M0. M1 represents model, M2 meta model, M3 meta model. Again, not to forget, we have studied CIM, PIM, PSM and PDM as viewpoints. So this looks at pyramid. This is called as pyramid of modeling layers. Right? Does it looks like pyramid? Yes, of course, the left hand side diagram. So at MOF stage, you have got the class and association. From there, the class and attributes are being picked up. Mu is the backward conformance relationship, mu. And the UML model is client. Client has got a name. So that is the way when you drag and drop certain notation on your workspace. What happens is at the back end, you make use of graph theory. And graph theory tells you how to have the nodes. Now use cases will be represented as nodes. Their relationships likewise includes or extends. They are being represented by the directed arrowheads. So it is a directed graph, right, representing these things. Going next, write once, run anywhere. That was happening about the code. Here we follow the principles. Model once, generate anywhere. So that is the beauty of PIM. All of your models are been standing at PIM level. That is platform independent model. Alright, and you can have multi-target code generation. So one specific model, that is one class diagram, can be done in so many options, right? In so many options which are being indicated. Okay, you can do it with C hash, Java, C++, and so on and so forth. So PIM has been mapped into PSM. So platforms of yesterday can be platforms of today, right? And tomorrow, isn't it? Now, today's technology, isn't it, is including, SOA, cloud computing, and so on. So typical enhancements are required to be there. So going next, you have got analysis model, UML meta model, then the design model, and then the code model. So PIM to PSM to code model. Code model is being represented as PDM, that is platform dependent model. So first step is iterate with PIM. Once that iteration has been there, look at this diagram. If you are satisfied with your work, go to the PSM, do the iterations. If there are corrections, go back, then come back and go to code model, iterate there. If there is a possibility of reverse engineering, go there. The backward arrowheads, okay, they are always been indicating of reverse engineering. T1 and T2 are been standing for transformations, whereas C1, C2, C3 are been for conformations. So the overall structure looks like this. MDA model is been classified into PIM. PIM has got CIM, that is as the basis, that is for use cases. We have got requirements, right? And requirements, they are the foundation diagrams in UML based on the use case diagram. So you can have the rest of the development. That's why it has been called as use case driven and architecture centric, right? Two important terminology: use case driven and architecture centric. So PSMs will be there, platform specific models. So PIMs will be migrated to PSM using the concepts of tagging, and then PDM will incorporate the code that is being generated for PSM, and you can have platform infrastructure, virtual machine, operating system, databases, and like that. So analysis, design, and code, likewise I have explained to you. So there is multiple level, migrations that will be happening. Those are being rated as transformations. That is from PIM to PSM to PDM. So what is the flow? CIM to PIM to PSM to PDM. Going next. Now you will see that there is something as coming up as a graph theory. So here just have this, look at this definition. A directed multigraph G consists of nodes, edges, and the mapping function, right? So the mapping functions involves how the edges are interconnecting two nodes, right? Here is the formula. Tau G is been guiding how edges are being drawn with the cross product of the nodes. Now, G omega mu is a triplet where G is a directed multigraph that we have seen earlier on, isn't it? And omega is itself is a model, as called as reference model of AM, and mu is the conformance relationship. Okay, so therefore, a meta model is a model that has its own reference model conforming to itself. Meta model is a model that is its reference model is meta model, and a terminal model is a model such that its reference model is a meta model, and the system is being delimited by the terminal model. So the same thing is being indicated technically. So now what is important thing is that the principle of limited substitutability. This I have said to you initially, but this is of course an repetition. A model M is said to be a representation of system S for a given set of question Q. If the question of this set is Q, the model M will satisfy the answers that the system would have given. Okay. So proceeding next, MDA. At the minimum, it is a more sophisticated way of using the UML. At the best, it is a practical and well-formed model supporting stuff. There is no consensus on common technology solutions. It was not there yesterday. Today also it is not there. So it focuses for interoperability and portability and raising the level of abstractions, right? That is keeping the stuff hidden from the user. That can be done with the help of adding the abstraction ladders, right? Well, so you can have two things. One is automated code generation and then automated model discoveries. Please do not misread this thing. Automatic code generation. There is no automatic code generation. It is automated code generation. Automatic means self-initiated kind of an code. Automated means that you have a support of the model, isn't it? The model has to be there. Now, the thing is that its promises, MDS promises is regarding implementation, integration, maintenance, and testing and simulation, right? So, virtually, the MDA is been useful not only in the development phase but also in the maintenance phase. That is, if you want to transfer a legacy system into the current scenario, then the MDA will be helpful for you. Right. Going next, the goals of MDA. There is a IPR, interoperability, portability, and reusability, and you will be mapping the platforms together to address these three critical issues, right? Interoperability, portability, and reusability, in short known as IPR. You know this word IPR previously also, but IPR is a technical, abbreviation which is used very widely when it is concerned with MDA. So now this is the terminology. Let us go quickly. Model is the representation of the system. Model driven means that the focus is centered around on the model. If it is data driven, the focus would have been on data. If it is code driven, the focus would have been on code. And architecture, you know about architecture that it is the structural arrangement of the system elements, right? But it doesn't speak about implementation. Viewpoint, what it is a technique for abstraction using a selected set of architectural concepts and structuring tools. View is the viewpoint model that represents the system from a perspective of chosen viewpoint. Now let us separate view and perspective very clearly. Views are well directed towards functional requirements, whereas the perspectives, they are guiding the NFRs, right? Views are related to FRs, perspectives are related to NFRs. That is, I can't say that is security view. Better than that, I should say security perspective, interoperability perspective, quality perspective. Quality dimension is a bad word. Quality perspective is the right word, right? So platform. Platform in general is a set of subsystems or technologies that provide coherent set of functionality, that is mixing together through interfaces and specified usage patterns, that any subsystem that depends on the platform can use it without concern for details of how the functionalities provided by the platform is implemented. So, a user of the system is not required to know how a functionality is being provided, right? The internal details are being hidden here. Now the last term is application, that is used to refer to functionality being developed. A system is developed in terms of one or more applications, as you all know. And now let us speak about platform independence. Many people have tried platform independence, okay, previous to me, especially with concerning with Java. What is Java? Platform independence. What is Java? Platform independence. What is platform independence? Java. What is the thing that happens is by so not a convincing answer you will receive. So here I always give an example of the railway station environment. Here, let us say that you are there on a at the railway station environment. It consists of multiple platforms. Platform number 1 to platform number 6. Trains, that is applications, they are coming and they are going on a platform. But it is not been fixed. Okay, what is platform independence is that a train which is usually coming on a particular platform must come on that platform. This is not the kind of a matter. What is the matter? It should be on time. It should not cause trouble to the target audience. Right? Applications are been coming in, okay, as a train, isn't it? Train has got an engine, okay. The bogies are been there. In bogies, the programs will get around with their data structures, right? That is their bags and all and that. Okay. So platform independence means a train that can arrive on platform number 1 can arrive on platform number 2. What is not platform independent is that a train number is scheduled to, always should come on platform number 1. It means that it is been stuck up with platform 1. It cannot go to any other platform. So smartly understand this term, okay, platform independence. I hope so you are like the example. So CIM, as I have told you, it focuses on the requirements of the system, the business dynamics of the system. PIM, here comes the question of UML diagrams, both in the analysis wing and the design wing, structural and behavioral diagram. PSM views that combines the platform independent viewpoints, right, to specific platform by using the concept of tagging. At the present, we don't know what is tagging. In our next session, we will come to know. Now, this is the theory about the CIM. So, CIM does not show details of structure of the system. Why it should show? It will only indicate the domain model and the vocabulary. It is for the domain practitioner. It is not for developer. Its role is to bridge the gap between the experts of the domain and the experts of design and construction of the artifacts. So, CIM closes the gap between the requirement analysis and the design. Next is the PIM. As you all know that all the UML diagrams are been falling here. Okay, so it's been there from structure as well as the behavioral kind of an part, and they are not affected by any of the platforms, isn't it? They are not platform specific unless and until you are forcing that one into a particular direction to a particular platform, they will remain PIM, right? PSM, just see the diagram. Through the diagram, you will understand it better. Multiple PIM diagrams are been given through the transformation and last step to the PSM. That is, model transformation is the process of converting one model. What it is the process of converting one model to another model of the same system. The model is been changed, but whether the underlying principle, underlying aim, underlying goal is been changed, the answer of that is no. You are speaking about implementation now, isn't it? When you are there concerned with PSM, going next is the thing that we require, that is PIM. There you have to create the model stability, that PIM should have the stability. So therefore you require iterations there, iterations to use case diagrams, iterations to sequence diagram, because first hand diagramming will not be right and appropriate. First hand diagramming will not be right and appropriate, and nobody can do that. And platform specific models will go around with platform change. Going next, here is the request response kind of an channel that you can see with the PSM, PIM and CIM. Okay, in the reverse order. That is, a particular platform is been selected. That is COM, DCOM, 4 CCM, Java, Enterprise Java Beans, XML, so for web services, and C# and .NET. You all know that .NET itself is a framework, right? Platform independent model, okay, independent of the middleware platform, independent of application structure is the characteristics of CIM. Now, this is again the repetition of CIM, PIM, PSM and PDM. So, a meta model generates the terminal model, class and association, that is employer and employee. There are many employers who can have many employees, but the same employee has been working there or not is a questionable thing. So this has been stated MOF levels in some different kind of a way. M0 runtime instances, M1 user model. User model is nothing but the terminal model. M2 is a meta model. M3 is a meta model. Going next, let us try to understand. This is very interesting. Okay, platform independence. Hardware has what? What? Just let me go back, isn't it? You haven't been able to focus it, okay? So let us focus now. What is platform independence? Okay, please be careful for certain 10 slides ahead. Alright? Hardware and software. Software execution platform is there, application software is there, application software interface is there. So APIs you must have used, application program interface, but here ASI, application software interface, is overriding the API. Let us redo this diagram again. Hardware and software, then for software you have got software execution platform, then you have got application software, then ASI. Application software interface. Application program interface is an interface that is being used for program. When you are there with the software, software consists of multiple programs, right? Now the next diagram adds up the bits, the OS, the device drivers, the software architecture, right? So 4 more things that are been added, isn't it? What they are? Bit support package, that is bit, device drivers, operating systems, SA and ASI. Still we are not talking about API. There is no API here. Here, bit, you already know. Okay, and we explained in the slides also. Here, lower level software detects and reports the hardware errors. OS, low level software, has to manage the interrupts. It's unique to the hardware. Device driver, one of the preliminary things. Low level software, again it is, that manages input and output up to the various external devices. But one of the key things is that device drivers are, even though they are unique to the hardware, they are not delivered within the hardware. So it's not a firmware. Yeah. Software architecture, you know much of the thing about software architecture now. I should not discuss about the software architecture. Next thing is ASI, very important. ASI, the thing that was been unknown to us. The boundary between the application software and software execution platform. Just see to it. What software execution platform consists of? SA, device driver and OS next to it. Bit. So, it is the duty of ASI to have a mode of communication, that is to have protocol engineering applied to application software to software execution platform, that is SA, device driver, OS and bit. So SA is not a theoretical stuff. Anybody can write the application software, but who will do the protocol engineering? How many of the people narrates the ASI, that is application software interface? No, we are just using or reusing the libraries. The specified methods by which the application software can make requests and use the services of the software execution platform. And this interface is specified by software execution platform. Next is, just try to see platform 1, platform 2. It has got the same story, right? Here you have to make the constants or what you have to make portable. Just see to it. When we say something is portable, what characteristic you want to make portable? By holding the ASI constant, you want to make application software portable. If you want to do that, then two ASIs should communicate with each other. They must know the nomenclature. There must be message transportations, right? And then you can make the application software portable to another one. Now this is the science of making something portable, alright? Making something platform independent. The rest of all is garbage. Okay? I'm very sure about what am I saying, right? Next is, can a constant application software interface be always be mentioned? I hope so. No. No. To fine tune the application software and make the services available, you have to fine tune. If it is a legacy software, previously built up ASI, you have to recorrect, you have to mold the ASI so that the language of the present ASI is mapping with the another ASI. Likewise, after the marriage, the bird is been going to the husband's house. So in that case, the tuning has to be done by the girl because the environment is unknown. And if flexibilities are not there, then people will not be able to accept the newcomer, the new entity after years together. Okay, that is but natural. Yeah. And even if it were been possible, okay, would one always want to maintain a constant application software? Just see to it, okay. For minimum level, you can have ASI constant. For most of the times, you have to make ASI flexible as far as reachability of application software goes. So, what is the ultimate goal? The ultimate goal should be to provide cross-platform compatibility. Cross-platform compatibility. That is, a train on platform number 1 can come on platform number 2 despite any implementation of platform specific changes. Right. That is, changes to the hardware platform, the software execution platform, or the ASI. Right. So this is a very big game. Right. Working around with compatibility amongst the cross platforms and the portability. So here we end up the session. I tried my level best to work out with the layering of the models